Okay, I'm going to walk you through a math concept that shows up all through math. You may have learned it when you were younger at one level. It applies in algebra. It applies, you would use it in calculus, college algebra, all over the place. So it's very foundational. So let's start with this. If I gave you this problem right there, what would you say about that? Hopefully you'd go, oh, that's 3 times 4. We're multiplying. That means 12. How about this? We call that a raised dot. I hope you know that also means multiply. 12. What about if I write it with parentheses? Multiply 12. What if I put the 3 in parentheses instead of the 4? I'm still multiplying 12. What if I put both numbers in parentheses? Multiplying 12. Okay, so that's awesome because this is what we're building on. You know that the parentheses means multiply. So that's what we're going to build from with the distributive property. So this is what I'm saying here. Distributive property, very important to math. It builds off the idea that the parentheses mean multiply. So here's the thing. We know from here, parentheses mean multiply. So suppose I did a problem like this. Well, this is 5 times x plus 3. That's what the parentheses mean, multiply, times. The key, though, is I have to distribute that 5. I've got to multiply by everything in my parentheses. So 5 times x is 5x, but I can't stop there. It has to be distributed to the 3. And 5 times 3 is 15. Let me do another one. Let's suppose I have 7 times x plus 4. Okay, multiply 7 times x, 7x, plus 7 times 4, 28. All right, another one. Okay, 4 times x plus 9. 4 times x is 4x plus 4 times 9 is 36. Kind of begin to see the pattern a little bit? All right, and at any point that you need to take a look at things more, just hit pause and look at these on your screen. I am going to erase them in just a second here, but I'll erase this over here so that we can work over here, and I'll keep that there for a minute if you need to refer back to it. So let's look at this then. I kept all these with positives. Let's get a little more involved here. Suppose I have 6 times x minus 5. Okay? And let me just write, these are 8, this is what this equals. Okay? So I'm still going to distribute. 6 times x is 6x, but I have a negative sign here. I have a minus. I just can't forget that. I got to write that down. And then still, 6 times 5 is 30. So I didn't change anything foundationally in what I was doing. I just can't lose that negative sign. Let's go 7 times 8 minus 4. Ah, that's funny. I did a 8 plus 4 over here. Well, let's look at this here. X plus 4 is what I meant. 7 times x is 7x minus 7 times 4, which is 28. Same problem I made up over here, only here I put plus, and here I put minus. So I have to really pay attention to that sign. It is wrong. If I saw this one and I said plus 28, it's wrong. And here's the easiest way to explain that. If you looked at your bank statement and it said you have $20, or let's go with the 28, you have $28, or if you look at your bank statement and it says negative 28, is there a difference? Yes, big difference, right? Actually, a difference of $56 between going up positive 28 and being in the hole $28. So that negative sign is very important. We can't just lose it. So I'm going to leave those. Now I'm going to erase these. Let me show you one more little step up with this. Everything I was doing so far was just x. Let's suppose it's 2x plus 3. Doesn't change anything. You just got to pay a little more attention. 6 times 2x. 6 times 2 is 12x. We don't know what the value is for x, but we got 12 of them. That's what that means. Plus, still have to distribute, 6 times 3 is 18. So just remember, you know, if I had written this part right here, if I had written 6 times 2x, you would look at that and you'd say, oh, well, that's 12x. That's all I'm doing here, okay? It's just part of a bigger problem. So it's 12x plus 18. Suppose I did 7 times 3x plus 5, okay? 7 times 3x is 21x plus 7 times 5 is 35. Are you getting the pattern? Because it is definitely a pattern. How about 5 times 5x? Let's go crazy with our 5s. Plus 5. 5 times 5x, 25x, plus 5 times 5 is 25. Okay, and it's important your answer look like this. I gotta have the positive sign because whatever this answer is, or this quantity is, I'm adding 25 to it. So that's important. I can't just leave it off. And I have to have my x because x has value. I don't know the value of x, but I know it has value. So that's exactly what your answer needs to look like. Same thing if I use a negative sign. If this is subtracting, still distribute 4 times 2x. 4 times 2 is 8x minus 4 times 4 is 16. Take another one like this. 8 times 2x minus 9. 8 times 2x is 16x minus 8 times 9 is 72. Remember that on the test you'll have your calculator. So if you want to check 8 times 9, go for it, okay? Be sure and use that calculator if you're concerned. Even if you're concerned with 8 times 2, or you want to double check your answer. Run it through the calculator, and that's what you'll get. Now there's one other thing. Hopefully you got all this down. I'm going to erase it all because there's one other situation that can come up that I haven't shown you yet. And that is if the number outside of the parentheses has a negative sign with it. Let's suppose I had negative 3 times x plus 4. Well, that negative gets distributed. It has to go toward everything in there. It's distributed with it. So it's negative 3 times x, which gives me negative 3x. And I could write it two ways, plus negative 3 times 4. If you look in your calculator, you will see a negative times a positive is a negative. So I have plus negative 14. This is the way the answer will show up. Adding a negative is the same as subtracting. Okay? So this is what your answer would look like. And I can guarantee they will give you answer choices that drop the negative here, that make this positive, things like that, to see if you really understand the rule. So you can't think, well, I'll get close enough. There won't be any getting close enough. You've got to know, you've got to understand the rule. In multiplying and dividing, a positive times a positive is a positive. A negative times a negative is also a positive. Signs are the same. A positive times a negative is a negative. And a negative times a positive is also a negative. So if you were dealing with two numbers at a time, if the signs are the same, it's a positive answer. If the signs are different, it's a negative. Very important to understand. But again, if nothing else, you'll have your calculator. So just use that negative sign. The very bottom thing of the calculator, it's got a little negative sign in parentheses. Just use that, and it will give you the negative answer, and then you'll know for sure. So let's try another one of these. -6 times, suppose I put a constant there. I have a numerical coefficient. Remember, that's what that's called. -6 times 3x is negative 18x. -6 times 4 is negative 24. Do that on your calculator. Do a negative times a positive, and you'll get that. Negative 24. Okay, suppose I had negative 9 times 2x, let's say with this, plus 5. Negative 9 times 2x, negative 18x, negative 9 plus 5, or times positive 5, I apologize, it's negative 40 minus 45. Okay, the last little challenge here, what if this is negative and this is subtracting? Okay, we don't need to get all concerned if we know our rules right there. -3 times positive 4x, negative 12x. -3 times negative 4, a negative times a negative is a positive. Again, if you use your calculator, it'll tell you. But this is plus 12. And I'll say again, they will give the answer choice both ways, so you're going to have to know. So really, hone in on that rule. How about -5 times 2x minus 6? -5 times 2x, negative 10x. -5 times negative 6 is a positive 30. Let me do that better. Okay, and one more.
Yes.
-9 times 5x minus 3. -9 times 5x would be negative, don't lose it, negative 45x. A negative times a negative is plus 27. You kind of following that? It's all about multiplying, and then don't lose your signs. If I were to get a little trickier, which is really not even trickier, if I were to just get a little longer, let me show you this, because I don't want you to get to something like this and panic. As I've said before, there's never a reason to panic in math. We can do this. We can do this, people. So let's suppose we had this. Let's say we had 4 times x squared plus 2x plus 5. All my rules apply. 4 times x squared is 4x squared, plus 4 times 2x is 8x, plus 4 times 5 is 20. You see that? I followed every rule, exactly the same. I did have one more term, but that's okay. I can handle that. Let's suppose I had a negative out here. Let's say I had -6 times, and let's put a coefficient here, 2x squared plus 3x plus 4. -6 times 2x squared is negative 12x squared. -6 times 3x is minus 18x. -6 times positive 4 is minus 24. Okay? And if it were a negative here, I've been only giving you positive terms. minus 5x minus 9. My same rules. Nothing's changing. Negative 4 times 3x squared would be negative 12x squared. Negative 4 times negative 5 would be plus 20x. Negative 4 times negative 9 is plus 36. So that would be your final answer. That's as good as you could get. Now, under one of the later tabs, it has a thing that says practice problems, and then the answers are actually under 2 separate tabs under that. That's clearly marked. So think through these things. You can read through the PowerPoint, understand this better, and then go through and do those practice problems and grade it.